So I finally decided to make a video on solving Cambridge A-levels chemistry equation. So we are doing today from October-November 2016, and in question number 1 this is. So 0.17 gram of sample of our group 7 chloride XCl4 reacted with water to produce an oxide XO2 and XHCl. So this is the equation. This is equation I, and what is the HCl produced was absorbed in 100 centimeter cube of 0.10 mole per dm cube solutions hydroxide and XS. In a titration, the unreacted sodium hydroxide solution required 30.0 centimeter cube of 0.20 mole per dm cube of hydrochloric acid for the complete neutralization. Calculate the amount in moles of hydrochloric acid used in the titration to neutralize the unreacted sodium hydroxide solution. So this is referring to this, that this is the titration, and we have given that 30 centimeter cube is volume, and we have concentration. So we have to take this centimeter cube of volume into dm cube. So we have to divide by 1000 and times its concentration. So from moles equals to concentration in times volume, we will get this 0.0060 moles as our answer. In part B, we have been asked that write the equation for the reaction between hydrochloric acid and sodium hydroxide. This means this is acid and this is base. So this will be acid and base reaction, which will give salt, NaCl as salt, and water means H2O. In part C, calculate the amount in moles of sodium hydroxide neutralized in the titration. So it is asking for the total NaOH neutralized. In this part we can see here the neutralized hydrochloric acid was 0.0060, and we can take this as reference. This is here is a mole ratio of 1:1 of hydrochloric acid and sodium hydroxide. So in this here 0.0060 moles of hydrochloric was neutralized from this same mole ratio. So the total amount of NaOH used in neutralization was also same, which is 0.0060 mole. So in part D, calculate the amount in moles of sodium hydroxide that reacted with HCl produced by the reaction in equation 1. So in here we have given the total amount of NaOH used for the reaction, which is excess, which is in excess, and this was here this is the total amount of NaOH placed, and used NaOH is this is the amount of NaOH used in the second reaction. So by subtracting the used amount of NaOH from the total amount of NaOH input gives us the amount of NaOH reacted in the equation 1 of the first reaction, which is 0.0040 mole. So here 0.0040 amount of moles of NaOH was used in reaction 1. So this question is asking for how calculate mole HCl produced by the reaction in equation 1. So we need to find the amount of HCl that reacted with NaOH, means this NaOH in the reaction 1. So from this 1:1 molar ratio, so this answer is also same, 0.040. In question number 5, F, calculate the amount in moles of XCl4 in the original 0.17 gram sample. So we have produced 0.0040 moles of HCl from the reaction 1. From this reaction we have produced 0.0040 of HCl. So this question is asking for what is the amount of XCl4. So the molar ratio is 1:4. So to find them to find the amount of XCl4, we need to divide this HCl mole by 4, because it's a 1:4 molar ratio. So this will give us 0.001 mole of XCl4. So Z, calculate the molecular mass MR of XCl4. So for this we need to use mole equals mass over MR. So we need to find MR. That is, this is the amount of moles. We can take it from here, and the mass, which is already given in our question. So from this we can get 170 gram, or we don't have to write unit. 170 gram is our answer. So in H, calculate the relative atomic mass AR of X and suggest its identity. So we have total MR, that's 170 gram. 170 gram of this compound XCl4. So we have known element, which is Cl, and it's Cl. We have 4 Cl atoms. So if we subtract 4 Cl masses of 4 chlorine from the total MR of this compound, then we will get the AR, or mass of the X. So we did the same here, and 28 is our answer. From the periodic table we can find that Si is the element having MR or AR equals to 28. So we found out Si. So here it is, 28.1. So we can take the identity of X as silicon, or Si.